All right. So I'm just clicking on that HTML. Everyone can see the lecture slides, right? Cool.
Yep.
All right. Wonderful. All right. Just got to move everybody's like Zoom heads around for a second. Yeah. All right. So data summarization. Up till now, we've talked a lot about just getting our data into R, a lot about just, really kind of essentials, right? Basic R. And then Carrie talked a lot about yesterday about just, how do you break your data down to a smaller size that is manageable? Sorry. Sorry, turning on the transcription just so you can follow along with what I'm saying here. Okay, sorry about that. So you can cut down on your data and actually start working with what you need to work with. So select and filter are great for taking out certain columns and rows that you want to work with. Arrange does some reordering of rows. Mutate can create new columns or modify them. So you may find you need to divide a column by 2 or something like that. Select and filter, of course, can be combined together, right? We learned about nesting functions. You can remove a column with select, and I think this is pretty handy. You can do the minus sign and the column name, and even provide a vector of columns here. And you can do sequential steps, especially using the pipes. The pipes are so powerful. You just chain one thing after another of the things you want to do. And that can be really great for making your code clean, easy to understand for your colleagues and for you, hopefully, later when you get back to it. And so if you need to review anything from yesterday, the cheat sheet is right here. Okay, so what are we jumping into today? At its most basic level, data summarization, I'm thinking summary statistics, okay? So these are probably familiar to most of you, but taking the mean is important to get a sense of, what's happening with your data. So you can do that with the mean function. You just put what you want to take the mean of inside. The SD function takes the standard deviation of X. Median, same thing, takes the median of X. Quantile is a little bit more complex. It displays sample quantiles of X. Default is min, max, and interquartile range. So it gives the 25, 50, and 75% quantiles. Range gives us two things. It gives us min and max. Okay, so those are additional functions, and we're throwing a lot at you, but you can always refer back to this slide. You can do sum of X and maximum and minimum, okay? And important to note that all of these have a special argument for removing missing data, okay? And I'll talk more about that in a moment. So that's important to know. It's this na.rm argument. Okay, so we're going back to vectors for a little bit. So I'm creating a vector here. It's what gets summarized and goes inside those parentheses. So if I make a vector X and I assign it these values, so 1, 5, 7, 4, 2, 8, and I take the mean of X, I get this output, yeah? So going back to R, creating some kind of vector and taking the mean. Wonderful. Okay, and that's what we expect. Happens pretty quick. R doesn't need to think very long about this. Okay, and same thing, range, sum work very similarly. Okay, so as I said, these functions have additional inputs regarding missing data. typically requiring the NARM argument, which basically removes NAs from the vector. So let's say I have something like this, and let me add some spaces just so things look a little nicer. I have something like this, okay? It's not a problem. Missing data is like, it happens, right? But if I try to take the mean of this, it's going to say NA, right? It does not know what to do with that NA, because maybe that NA means it's off the chart. It's a million, right? And that's going to actually give us the wrong idea. And so by default, R doesn't want to make any assumptions. So I can use, if I'm like, oh, that NA, it was just like, I didn't get my measurement that day or something like that. So I can add this NA.RM equals true and just take the mean of the numbers that are present, okay? And so R doesn't do any like weird imputation or like try to guess what the NA is. It literally just drops it, okay? And so if you do try to take mean of something with an NA, you'll get an NA out. If you try to take quantile, it's slightly different output. It will give you an error message, right? So it's a little bit different, but you can also remove NAs with that exact same argument from quantile. Okay, so we'll talk a little bit more about data types and classes later today, but importantly, you can only do summarization on numeric or what's called a logical type. So not characters, no words, right? Like what would the mean of several words be? I'm not really sure. Maybe the median could make sense, but yeah, so you're always going to be using numbers for summarization in this way. And when I say logical types, I just mean a collection of true, false, true, basically those two options, because R interprets false as 0 and true as 1. Okay, so you could add up the number of trues or something you have in your data set. Okay, but if we have these as character type, it's like invalid type. I can't do math on that. All right, so this is all great, you know, but why do we want to work only on vectors? We want to actually make this applicable to our data. So okay, how does this translate to when we actually have a data set? So let's go ahead and load some data to play around with. So we'll load the JHU cars data set, and we'll need the JHU-R library to do that. So if I go over to R, loading that library, wonderful, and looking at the head of the JHU cars object that comes with that package, okay? And that's very similar to MT cars. I think it's actually the same thing. So, all right, let's see how that works out. All right, so let's first just talk really quickly about something you might see, which is a base R notation. You might see a $ to refer to a specific column in a data frame or a tibble. So if I have JHU cars, I can use the $ to pull out the HP column. And that column is what goes into the summarization function. Okay, so instead of that made up vector that we were using, now I'm working with a column. Okay, so I can do something like sum JHU cars and HP, and it will go ahead and add that up for me. But we're not going to use $ notation too much, just because it's a base R thing and we want to do things the tidy way. So let's talk about that a little bit. It's a little bit more text, but it works better with if you have previous data cleaning or any kind of other steps, subsetting steps. This can be a little bit cleaner. So instead, let's take the JHU cars data set, we'll pipe it into this pull function, which extracts that column we're interested in, turns it into a vector, and then pipe it into whatever that summarization function is that we want. Okay? So instead of what I have here, I could have done JHU cars. And I think it's always like, makes a little bit more sense to me. You start with the data, right? It's a little less backwards grammar, I think. Pipe this into pull and pipe that into the function we want, okay? So I should get the same answer. It's just slightly different formatting here. Okay, so just some more examples. So taking the data set, piping it into pull, I tell it what column I want to actually get some summarization on, and then I tell it the function that I want to use. Okay. Quantile, okay, just this bottom example here, Quantile has this really cool argument that you can provide called probs if you are interested in a specific quantile value. So if I want to do, instead of sum here, I want to do quantile, and I just want to know the 20 percentile or something like that. Okay. And I run that, I can get a value for that. Okay. Okay, so let's get a little bit more complicated. So there's some basic statistical summarization that you can do that's a little bit more powerful. It's not just one column that we're thinking about. So I'm going to talk about some of these. So row means takes the mean of each row of X. So kind of a little counterintuitive, but creates a new column for that. Column means takes the mean of each column. Row sums, very similar, takes the sum of each row of X. Column sums takes the sum of each column of X. And summary is kind of nice for data frames. It displays a ton of information on your numeric columns, displays the quantile information, how many NAs you have, min and max, things like that. Okay, so let's play around with a slightly different data set, one that is a little bit more realistic than the CARS data set. So let's read in a Tibble, our very special data frame of values about tuberculosis incidence. And so this is also in the JHUR package, so you can load it in using that package. And as Carrie mentioned yesterday, if you don't want to load the library, you can use this double colon to indicate the library or indicate the package it's supposed to come from. So because I already have JHUR loaded, I can just do read TB, okay? And that's just going to show me the data, but I want to save that as TB here. Okay, so now that's in my memory here. Okay, so let's check out the data. Let's take a look. Okay, so I've got a Tibble, I've got some kind of funky column here, but I have countries in that column. And then I have years and some kind of incidence number per year per country, okay? So looking a little more in depth on the columns that I have, I can see that this one is a super weird long name, kind of clunky here, but it gives us a little information. It says, okay, well, the incidence is per 100,000 people per year. Okay. Kind of important to know, right? You don't just have 168 cases or 25 cases or something like that. Okay, so before we go any further, let's rename that ugly first column using the rename function that we learned about yesterday. So in this case, we'll have to use backticks, okay, because there are spaces and funky characters in the name. So if I were to take, I'm just going to copy this here. Or actually, let me type it out just to kind of show us how that will look. So rename, and I want to name it country, because that makes sense, right? These are countries here. And I can autocomplete here with tab, and I can stick this weird column in here. And you'll notice it automatically adds those backticks, okay? So this looks much nicer, right? If I don't include those backticks, what happens? I'm gonna get, yeah, it's just not gonna work. It's not expecting to find spaces in a column name like that. All right, so we've renamed it. We've reassigned it. And we can use call names to show us the column names and show that the country is renamed. So if I do, make sure I reassign it and do call names TB, I should see that country is the first thing. Okay. All right, so let's get into the weeds a little bit here. So there's a function called summarize, which creates a summary table of the column that you're interested in. Okay. So if we take the data TB and we pipe that into the summarize function, we have a couple different things that we need to provide. So the first thing is whatever we want the name of this summary column to be. So kind of a common thread that we're seeing is that new name goes on the left-hand side. And on the right-hand side, we'll want to include some kind of function here. So maybe we're summarizing in a way that collects the mean. And we have to specify the source column. Okay, so taking that down to this example, we're going to create a new column called mean 2006. And what is actually going to be in that summary table column? It's going to be the mean of the 2006 column. And remember, I had all of these columns and they were pretty much just years, right? So looking at this, I have years for my column names. So I'm going to do the mean of 2006, and I'm deciding, okay, I just want to get rid of any NAs. I don't think they're probably off the chart or something like that. So I'm going to go ahead and do this preemptively. Okay, and so what we can see is the mean of this column is 135. Okay, so this is kind of a roundabout way of getting to something that looks a little bit more like this, right? Pulling that column out and taking the mean on it. But I promise there's a reason we're getting into this. Okay, so instead of just extracting one column out at a time with pull, summarize is awesome because it can do multiple summary operations at once. So it can use multiple of those summarization functions. Just separate them by a comma. So the first thing we have is the mean of 2006. And as expected, this takes the mean of the 2006 column, removes the NAs, and then I say, oh, okay, I want the next thing in the summary table down here to be the median of 2007. I'm going to take the median of the column 2007, and same thing, going to remove NAs. And then the last one, I didn't actually, maybe I forgot to provide a column name here. You notice there's no equal sign, there's no new column name, there's just the summarization that I wanted to do. And you'll look down here at the results, I have those columns that I named, but then I get this really not pretty name for this last summarization that I provided. So this median 2004, it just kind of copies this down there, which is really not very pretty. So when we forget to provide a new name, output is still provided, the output is correct, but the column name is messy, and that's not going to be fun for us later. So let's correct that error. Yeah, this looks better. Okay. Or not an error, but let's correct this not nice column name. Okay. And so just a reminder too, the summarize function comes from the dplyr package. You probably already loaded it to do some filtering or some selecting and things like that, or you loaded it with the tidyverse package. So a lot of what we're using in this class comes from dplyr. It's kind of the powerhouse here. All right, so we're getting into a little bit of iterative stuff. So this is a little bit more challenging. So if we combine summarize with across, we can do some really nice quick summarization across a bunch of different columns, hence the name, right? A bunch of different columns without having to kind of list all of them out like this, okay? So the general format's a little bit more complicated for across. We tell it the columns we want it to go across, a comma, and then this tilde symbol. And we tell it the summarization function we want to do. And then we include this kind of funky character, period X. Okay, and then we can tell it any additional arguments that we need for that that summarization function. Okay, so probably easiest to look at an example here. So same thing, if I take my data and pipe it in to summarize, across goes inside. And so here's across. And I'm saying, okay, well, the columns I want to go across are 1990 through 1993. Okay, so I'm providing that in a combined vector. Okay, we'll get into more examples of what you can put here in just one moment. But so those are the columns I want to go across. Next argument is gonna be this tilde, and then I'm gonna do, okay, I want the sum across those columns. So you'll just do sum, stick in this symbol here, and then include any additional arguments such as this na.rm equals true. Okay, so this is pretty advanced stuff, but it does save us a lot of time, right? I don't want to have to type out every single column that I want to summarize across. And so I get this nice little table out, right? So I didn't have to list out everything. I get a good summary giving us the sum across those years. And so something, let's see, kind of interesting that there's fewer cases in 1990 than in subsequent years. So if I wanted to get kind of a global sense of what's happening across all those countries, this could be a good option for me.
Just wanted to mention that there were some questions about backticks and why we needed them here.
Yeah, good question. Yeah, thanks for chiming in. So let's go back to R here. So remember when I read this data in, I had this really funky column name, right? So let me read this in one more time. If I am pulling out a column and looking at the columns of this data set, I have lots of spaces, I have parentheses, I have stuff in here that's going to make it hard for R to read this. Okay, so if I select it, it's going to put it in backticks, and I should include backticks anytime I have some weird symbols. Okay, if I was doing something like JHU cars HP, there's no weird symbols in this HP column name. Okay. And similarly, you'll also notice that the years have backticks. This is because it just interprets it as a number otherwise. Okay. So a lot of the functions in the dplyr package, they kind of assume that if it's text, they assume that you would have had quotes there, which is a little tricky. But anytime you have a year, I would err on the side of caution and use those backticks, as well as if you have any spaces or kind of weird symbols in your column name. Yeah. Okay, so yeah, like here, I don't need backticks because it's just text. There's no weird symbols. But if I wanted to name it country name, right, that's not going to work. I would need backticks because of that space. Okay. All right. Let's keep going. All right, so maybe I don't want to provide a vector of column names, and I want to use my select helpers. So maybe I want to do any columns, across columns, and I want to do any that start with 2, right? So I want to do any year basically after, including 2000 and beyond, right? I could do also like contains 0 or, lots of options here. Our select helpers can help us pick certain things, okay? And maybe I want the range here instead of the sum. And again, using the symbol .x, and then any additional arguments, including removing NAs. So we can see that I have a summary down below of all of those years that start with 2, and the range goes from min to max here, 0 to 800 some. These numbers kind of make sense with that. So yeah, those tidy select helpers, we can get a little bit more information about those. Let me just get rid of this. If I go to select helpers, and click on that first result, it's telling me a couple of helpers that can help me match patterns and kind of get what I want in a programmatic way, right? Instead of having to list them all out. So matches, starts with, ends with, contains, all that good stuff. Okay. All right, and as I said, talking a little bit about col means and row means, importantly, these require all numeric data, okay? They're assuming you have all numbers, okay? So let's see what the mean is across each row here. So if we had to basically summarize by country, right? Remember, I had this country column, and I just want a summary across all those years. I want to kind of clump it down. Okay. Because I need all numeric data, I'm going to actually have to use the opposite of row names to columns, which is column to row names. And I'll just take that data set. I could use the pipe here, but I'm going to take this data set TB and tell it I want the column country. I want that to actually be the row names. Okay. So if I go here, TB2, and let me put this in my script here, best practice, because I might need it later. Okay, so I'm going to do column to row names from the Tibble package. I'm going to tell it TB, and I'm going to tell it, I'm going to make sure I run this again. I'm going to tell it I want that var to be country. Okay. Looks good. All right. So if we look at TB2 now, you can see that instead of having a column for country, it's actually just the row names. Okay. And again, if I look at the head here, I can see that. And so then all I have to do is do row means of TB2. And again, I want to make sure I remove those NAs. So what happens if I kind of run it without? I might get some NAs in my data, depending on if there were some NAs in that country. So yeah, Montenegro had an NA, so we don't get a mean there. But let's say I include that argument and boom. All right, so now I have a really large summary across all of my years for each country. All right, so call means gives us very similar output to the functions we've already seen with summarize and across. So if we know we want to do this across all of our columns, they're all numeric, feeling good about that, I can do call means TB2 and NA removes true. And what this is going to do is give me a summary across every year, but it's condensing down across country, right? So I end up with just basically a set of those years and the means for those, okay? And so you'll see that if I do this summarize across and do all of the columns using call names, this is basically going to give us the exact same thing, okay? So 105 something, 105 something for 1990. Those numbers are the same, but I do want to point out that these outputs are different data types, okay? So depending on what your next step will be, I believe this gives us a tibble here, and this gives us a vector. So, you know, if you wanted to do some kind of mean here or some other analysis, you could, versus if you wanted to export like a CSV or a table or something like that, this might be more appropriate. Okay, and I mentioned briefly the summary function, which can give us a rough snapshot of each numeric column. Character columns are skipped. You don't need to worry about specifying. You can literally just type in the data set and get tons and tons of information, right? So it's saying, okay, well, country, you've got a bunch of different entries, but it's character type, so I'm not going to give you any math. But 1990, it's giving the mean, quartiles, number of NAs. We've got one NA in there, and so on and so on. Okay, so summary is a nice way if you're like, I can't remember all of my functions. A good way to get tons of information. Can almost be overwhelming, but if you kind of want to get one function to kind of start and get your feet wet, this could be a good option for you. Yeah, so you do need to specify what you want, right? So for summary, this is what it's giving me. Like I said, NAs, and then the quartiles, mean and median. But then if you wanted to say, okay, well, all I want is the I want the mean of 1990. Oops, I am just struggling to type here. And oh, sorry, I'm going to pull that. Let me. Typing live coding is always a struggle here. So I want the mean of that. I can run that. I have to drop my NAs, right? Okay. But if I want standard deviation, all I would have to do is copy that and do the SD function, right? Okay, so pretty big standard deviation there.
Ava, we also had a really good question about just going back over in the across function what the dot X is about.
Yeah. So this is kind of a complicated notation. So this is called a per function. It's a whole other kind of realm of R, and we're not going to get really into that too much. But it's telling us, okay, well, the following is kind of like the formula I want to use on all of these columns, okay? So in this case, I use this X to denote, it's like a kind of like a wild card for all of these column names, okay? So this is where the iteration comes in. It's plugging in each of those columns into the .x every time, okay? So it's really just a stand-in for that column name. Okay, great. Yeah, so this na.rm equals true is going to be like our heavy lifter, right? So please don't forget that if you're getting some NAs and they look weird. Okay, great. So I think with that, we'll go into the lab and there'll be plenty of time for questions in there. I don't know if we'll finish before break, but we can always come back to the lab after break too. All right, everyone can see the lecture slides, all good?
Yes.
Okay, great. All right, let's keep on going. More summarization stuff. All right, so for this next bit, we'll work with the youth tobacco survey a little bit more. And just as a reminder, we've got the year, we've got a couple different states, abbreviations, a topic for the survey, you know, what kind of questions were answered. So there's a lot of like categorical data, okay? And so I can read this in from the JHUR package using read YTS. So it's nice and easy to get that into my space to work on it. Okay, so let me just create a new chunk down here. Okay, so I already have JHUR loaded, so I can just do read YTS. It should come up with a little preview. Okay, and I want to assign that to YTS. All right, so if we take a look at the head, just like in the lecture notes there, I can kind of see a little preview of the data. Okay, so let's work with one column as a vector using pull. Okay, so again, let's take out those state descriptions. So we'll do locations. It is the data set. We'll pipe that into pull just like we were doing. And we were doing location description, right? Excellent. All right, so run that. I shouldn't get any output, but now I have the locations object, which is a vector. All right, so maybe I'm interested in the unique value. So we talked a lot about numeric stuff up to this point, but you know, maybe we want to know how many Arizonas we have in our data set, or what kind of values I have. So unique is a good way to get started. We'll return the unique elements of a vector X. So if I do unique, let me do it up here. Let me make sure I save it. It will give me a output vector of all those unique values. Okay, pretty straightforward. Okay, so combined with unique, length will tell us basically how many unique values we have. So how many unique elements do we have for locations? All we have to do is tack on length and run that, and it tells me, oh, I've got 50 unique locations. First thought is maybe I have 50 states, but clearly I've got some things that are not in the 50 states. So national, a whole value right there. So perhaps I'm missing some states, right? Okay. Okay, another way to kind of get at some information on our categorical data. Maybe we want to know the number, the counts, the frequency of those unique elements. A super easy way to do this is with the table function. So if I do, and again, I'm still working with this column that I pulled out, right? So if I do table locations, I can get a frequency table. So there's 6 responses from Puerto Rico, 23 from Nebraska, 567 from Mississippi, etc. Okay, so a way to do this with our basically our tidy grammar using dplyr, we can use count directly on a data frame and column without needing to use pull. So this actually gets us there a little bit quicker. So instead of having to do locations, pull it out, then do the table, I can just go straight there. So I can do YTS count and let me get rid of this extra space. Count and location. Oops. It would help if I could type correctly. Location description. Okay. And I was using tab to autocomplete there. What does that get us? A nice little frequency table. So here we had kind of a different looking output, but the values should be the same. So if I see, okay, Alabama 378, go down 378. But I think this is a lot nicer. It's a table, you know, I could write that to an intermediate file if I'm interested. A little bit nicer to have this in table format. Okay, so again, this works directly on a data frame without needing to pull the column first. Okay, so maybe I'm interested in a little bit more breakdown. I'm not only interested in the state, the location, but maybe some other categorical variable as well. You know, maybe you have state and you have, you know, like middle school or high school, or you have the kind of survey that's being done. So the topic was whether there was cessation of tobacco use, cigarette use, smokeless tobacco use. So a couple different types of surveys. And you can see that those numbers are further broken down. Okay. So nice if you want to kind of do one of these like cross tables here. Okay, so important to note that when we get this summary of our categorical variables, if we use count, we're going to get NAs as their own category. So say we had NA for location description in our data. We would also get a count for the number of observations or the frequency of that, but we don't get that from table. So just something to be aware of. Table is not going to give you that information. All right, now we're getting into something really fun. So doing grouping on data. Okay, so this function group by is really powerful. It comes from the dplyr package, just like some of the other stuff we've been talking about, but it allows you to group the data set by variables and columns you specify. So what do I mean by that? It's really just saying, okay, I want to break this data down by something, right? By variables or columns. So if I've got my data here, YTS, and I pipe that into group by, I'm saying I want to group by the kind of response that I have and create a new object that's grouped. All I see that's different in the data, so nothing has changed, but I have this group indicator here. So going back and forth, the only change is that now I have group, okay? So it's grouped by response and it tells me there's 4 different responses, okay? So why would I do this, right, if it doesn't change my data? Okay, Grouping doesn't change the data in any way, but it changes how the future functions operate on it. So now when we summarize some numeric value, we can get the response by group. Okay, so group by coupled with summarize is where you get the really powerful stuff. So if I take this YTS grouped data set and pipe that into summarize and say, okay, well, I want the average percent, this data value column, which is percentage of respondents. I want the average percent, but I want it across those response groups. And then I want the mean of that percent response. So instead of just getting the overall percentage of respondents, I'm getting the percentage of respondents by group. So you can see I've got response, current, ever, frequent, NA, and I've got some kind of average summarization value over here. Okay. Okay, so we can use the pipe. This is where, you know, why the pipe is really handy and why we're teaching it. So it can be really nice to string these together, right? So you only have one kind of block of code. You can take YTS, pipe that into a group by, or grouping it by response. And then we pipe that into summarize. Okay. And so if we're doing naming a new column average percent and getting some summarized value here. So maybe we want median percent. And we want that to be median of data value, I think was the name of the column. Way down here, data value. Okay. NA.rm equals true. Okay. So what is this going to get us? Okay. So we now have it broken down by response, and then we have some value, and of course we can add multiple arguments here. So if we wanted to do mean too, we could certainly continue on. Okay. All right, and so if we ever want to ungroup our data, we want to kind of get the whole picture summary and not broken down by group, all we have to do, and this should be an arrow, I'm sorry about that. Should we need to do that, we can use the ungroup function on the data, and we will no longer have the group attribute for the data set below. All right, there may be situations where we want to create a new column that maybe it has the mean value for each year in this case, or mean value per state, because we want to compare, you know, the values we're seeing to some kind of mean. We can just add that with mutate. So if we take the YTS, pipe that into group by year, and then say, okay, well, I want to create a new column with mutate that is called year average. And that year average is going to be a mean of the data value with NAs removed. It's going to create a new column that is indicative of the year average. Okay, so let me show you a little bit more. I know this is a little bit kind of tricky. So we'll take YTS, we'll pipe that into group by year, right? And if we run this, right, data is now grouped. The group is year, there's 17 years. And pipe that into mutate, year average is mean data value na.rm is true. Make sure I don't forget my parenthesis there, and run that. Oh, and I want to select, because this is a big data set, right? I want to actually see those columns. So I want location, and maybe I want data value. And I also want this new column that I created. Okay. All right. So what's the year average? So for 2015, all these values are the same, but let's say I want the tail end of this data to kind of prove to myself that it's different. I can pipe that into the tail function, and you can see that the year average is different for 1999. Okay. All right. So that's useful, again, if you want to create a new column based on some kind of grouping in your data. Okay. Oops, jumped forward a little bit. All right, so one more summarization function that I think can be really useful with summarize is this super easy n function. So if I stick this in with summarize, it counts the number of observations, which I think can be really nice. So here you can see the output. I've not only grouped by year and summarized to get the mean data value, percent response per year, but I also have created a new column n in the summary table, which has just the frequency or the count. Okay. Because maybe you see a weird value for the mean and you're like, I wonder what my sample size is. A good way to check that. Okay. And so with that, let's go and work on this in lab. All right, welcome back, everybody. You had a chance to stretch your legs and stuff. So the next bit we'll be talking about is getting into something I think is super exciting, and that is a little bit of plotting. Not plotting some devious plan, but plotting figures. Okay. All right. All right, so let's continue on. Everyone see my screen and everything? All good?
Yes.
Okay. All right, we're going to preview plotting a little bit. So in general, plotting is an important component of exploratory data analysis. And so what we're going to talk about just now are some really rough plots to use in real time to just briefly explore your data. These are not publication plots. These are just super quick, super rough idea of what's going on, but we'll go over formatting and making plots look nicer a little bit later. So this is really just for you. It's to make sure that the data is kind of meeting your expectations and doing what you think it should. Okay, so let's play around with this a little bit. So the first thing we may be interested in doing is a histogram. So let's say, add another chunk down here. So let's say we are interested in just understanding the distribution of some column, right? So I'll go ahead and take the data set. I'm going to pull out that column just like we did with looking at like unique and length and things like that. So pulling it out as a vector, I'll go ahead and save this as MPG. Okay. If I look at MPG, it's just a list of numbers, right? But I'll go ahead and run hist. I can just say MPG. I can run that, or I can specify that I want the x-axis to be MPG, and I'll go ahead and run that, and I get a nice little histogram in the plots pane. Okay, you may see it preview down here if you've got your RStudio settings a little bit different. So yeah, I can see that there's kind of a range here. Doesn't look like a perfect normal distribution. Got a little spike here at the end, but looks okay. I can use the breaks argument to tweak the resolution a little bit. So if I wanted to say, okay, maybe I want more than 5 bins here, let's say maybe I want 10. It breaks it down a little bit further, and so I can kind of see a little bit more resolution here with the histogram. Okay. So again, that's the hist function. Okay, so maybe I have a couple different continuous variables, and I want to plot them against each other on the x and y axis. So maybe let's create an HP object for horsepower, and we'll pipe that in. So again, we're creating a vector. And so let's plot a scatter plot. This is a little easier. It's not even hist, it's just plot. The x-axis, let's make that horsepower, and let's make the y-axis mpg. And let's make sure we run that, and then that. All right, so we see a little scatter plot. Looks like as horsepower increases, miles per gallon decreases. That kind of fits with what little I know about how cars work, but that makes sense to me. Okay, and again, specifying the x and y axis and using the plot function. You don't need to specify x and y, but I think it's best practice just in case you mix up the order. All right, and finally, box plot. So you have something that behaves in a continuous way. So here we have 2 continuous variables, 1 continuous variable, but maybe we have something that behaves like a categorical variable. In this case, the different cylinder sizes. They are numbers, but they're really more categories. They're not really like continuous number of cylinders. You can't have 5.5 cylinders, right? Versus something continuous. So what does that look like? Let's create a new variable or new object, CYL. We'll go ahead and pull that CYL column. Okay, and we'll create a box plot. And this is a little bit different. Okay, so instead of specifying x and y, you specify a formula. So you have the function box plot, and then the argument formula, okay? And you put on the y-axis first, and then the x-axis second. It's a little bit backwards, but you can think of this as kind of like an equation, right? So the y usually goes on the left-hand side of the equation, and then you have some kind of slope in a regression model on the right. So what does that look like? So if I do formula, and that is, I want HP to be my response variable, basically, and CYL to be my categories on the bottom. So what does that look like? All right, so horsepower increases, looks like with number of cylinders. Very cool. Okay. And so what if I had treated this cylinder as like more of a continuous variable? So if I did like plot x is equal to CYL and y is equal to HP, I don't get an error, or it's fine. It still plots it, but this is a little like harder to read, right? Like I can still see the points, but they're all overlapping, and they're, just kind of on this one point. It doesn't really make sense for me to have 5 and 7 on here. This is going to tell me a little bit more information. Okay, so I think that's pretty much it. So we have summary. So just to give us a summary, and there was one question that came up in lab I wanted to cover real quick. But summary stats, such as the mean function, they work with pull. So if you wanted to get kind of a summary of just a single column from your data, use the pull function with that. Summary can give us a lot of information about our numeric columns. Summarize is a great way to create a summary table of the columns that you're interested in. And we can couple this with across to programmatically select a bunch of different columns. You know, if we have some that all start with 2, we can use across to do that really easily with not a lot of code. Okay. Count, what unique values do you have? You can count up the number of, or the frequency for your different categories. You could also use pull and table or unique combined with length. But remember, this will require a vector, so we're going to have to use pull with that as well. Group by changes all subsequent functions. Remember, it's like it's an adverb. It's not an object or really like doing something to the data quite yet, but it changes the way everything else happens afterwards. So combine it with summarize or combine it with mutate to get statistics per group. And then plot and hist and also box plot are great for a quick snapshot of the data. And then one last thing, it sounded like maybe there was a little bit of confusion around when to use count and when to use n. Okay, so let me just break line here a little bit. So, you know, if I have JHU cars and I want to count just the number of rows, I can do that. But if I do n here, that's not going to work. It is not really meant to be the first thing that's piped into, right? So the n function comes in handy a lot when we're summarizing. Okay, so this work. Let me use a different data set example. So if I'm using the bike data set and I want to summarize that total n is equal to that n summarization function. So this is like, you can treat n like you would treat like mean or sum. It's more in common with that than with count, even though it can give you very similar data. So here we go, total number of n, and then I can get the same answer if I pipe that into count, right? So they give us similar information, but n should really be used inside something like summarize or mutate. Hopefully that makes sense. But yeah, they do sound like they would do really similar things, and they do give us similar information, but their usage is a little bit different.